Welcome, everyone. Thank you for joining us today for this special edition webinar. It's a special edition webinar because the presenter, Dennis McCullough, was also a presenter at the virtual 2020 AOCS annual meeting. And we are now having him back to do an extended presentation of his annual meeting presentation. Dennis is the vice president of the Plus Group and has over 40 years experience in process and packaging operations within the food and beverage, paper, beauty care, baby care, cosmetic, household, and healthcare industries. For today's webinar, all the attendees will be muted. Dennis will take questions at the end of the webinar. So as those occur or at the end of the webinar, just write those into the question area on your control panel. If you do have any technical issues or need assistance, please use the chat and I'll be right with you. So again, thank you so much for joining us for this special presentation. And with that, I will turn it over to Dennis.
Excellent. Thank you, Amy. Good afternoon, everyone. As Amy mentioned, I will be presenting on FSMA, Food Safety and Modernization Act, specifically on equipment, cleaning and sanitization requirements within the food and beverage industry. Without further ado, we'll go ahead and get started. The overall agenda is listed on the screen. And in essence, what we'll do is we'll do a short introduction in terms of contact information as well as an individual bio. We'll talk about the Food Safety Modernization Act, specifically again on the background, what our focus is today, which is subpart L, the critical dates in terms of enactment of FSMA, and then we'll discuss mitigation strategies, focusing on our vulnerability risk assessments, the corrective actions required, and we'll finish up with our food defense plan, covering cleaning and sanitization requirements. Individually, you can see the bio that's present there. As Amy mentioned, 40 years within various industries. I also serve as a hygienic design consultant with some major companies of CPG, food and beverage, pet care, chemical, and cosmetics. Individually, I've actually have trained a number of individuals on hygienic design standards for equipment and facility designs. Personally, I've taught over 1,500 people to date since 2009 globally on the principles of microbial or hygienic clean design standards itself. As noted, the contact information is listed there. I've even provided primary phone number as well as cell and email. So to give a background associated with FSMA, let me start by saying that the Food Safety Modernization Act originated because 48 million people were getting sick. 128,000 of those were hospitalized and 3,000 died. In fact, the CDC has said this year alone, 1 out of every 6 people will actually get sick from a foodborne disease. Now, individually, again, the FSMA Act was signed into law in 2011, but it is the most sweeping reform in regard to food safety laws in more than 70 years. Specifically, it follows the FDA 21 CFR section 110. And the point of emphasis is these items are enforceable. That includes the inspection of records, the registration of food facilities, FDA performance standards, the authority to collect fees, as well as a mandatory recall authority and administrative detention. That could be involved up to and including jailing of the food company executives. The goals of FSMA stand that we want to assess and implement preventive controls on a broad basis. So in essence, what we want to do is we want to fully understand what and where are your risks and what appropriate controls are preventing those individual risks itself. In essence, the FDA expects the following: that they will be going from a reactive to proactive in the preventive strategy, which is the essence of FSMA. And the expectation is that the preventive control rules for the initial enforcement focus. Expectations that there is an active monitoring program within your food facility with corrective actions taken that are proactive in your food safety plan itself. Specifically, Subpart L deals to protect food from intentional adulteration, where the intent is to cause large-scale public harm. And again, for the purposes of this review, we will focus on that Subpart L only, as mentioned, which addresses equipment, building design, and cleaning and sanitization procedures. This rule does require that a food facility must implement measures to protect food against intentional adulteration. And in addition, it requires domestic and foreign facilities to address vulnerable processes in their operations to actually prevent acts that could cause large-scale public harm. Now, I realize this is a little bit of an eye chart, but hopefully you'll focus on the dates to the right of the eye chart itself. But this is a publicized FSMA document that identify the critical dates of implementation for food facilities. Individually, they're broken out by the size of the company. So for instance, a large business is considered to be 500 employees or more. And then there's smaller business aspects as well as very small. Now, one thing I want to emphasize with these dates is that a lot of these dates that you see have either come or here now or very, very soon for the small businesses, very, very close in hand. So in essence, what the emphasis here is FSMA rules are enforceable based upon these dates. The FDA guidelines specific to Subpart L, again, identifying possible routes of microbial contamination in produce, it sets the requirements for the introduction of pathogens. So in essence, equipment, tools, and buildings are one identified route of contamination because they may contaminate the produce with pathogens, and adequate cleaning and sanitization is an important part to minimize that contamination. The potential for contamination is increased if those equipment and tools come in contact with the product, as well in the farming sense for growing, harvesting, packing, or storage activities that take place that are not sanitary. So in essence, we as food facilities have to make sure that our equipment, tools, and buildings are clean, and they are also of adequate design and construction to be adequately clean and sanitized and to minimize the contamination of our products. The FDA has identified 4 key processing activities that are most vulnerable to those forms of adulteration. They include bulk liquid receiving and loading, liquid storage and handling, secondary ingredient handling, that's the step where the ingredients are added other than the primary ingredient to the food and then are combined with the primary ingredient, and finally mixing and or similar activities. The point that you must take away from this slide is that anything associated where the product is open and is not sealed into the primary package is open for FDA control. The other thing that in terms of minor ingredients, the third bullet, what's important is even if you when you're looking at the inspection of your primary and minor ingredients, you need to understand, does those ingredients have what's called the TVO? That stands for total viable organism. That will determine initially the microsusceptibility of the product. If the product or the ingredient itself has a TVO count, it is microsusceptible. The other point is when you're adding water to something, you immediately make that microsusceptible, even if the ingredients are not microsusceptible. So those 4 steps, as noted, are required by FSMA are the following. Number 1, that you must perform vulnerability risk assessments. 2, what are the actions associated? Again, you create the action steps directly out of those risk assessments itself. 3, a question needs to be asked, how do I know that my corrective actions worked? And finally, there must be a feedback loop in order to adjust the risk assessment resolutions. So I won't take the time to go through, the bulk of this discussion here, but just understand the risk assessment is a requirement. If someone has identified, and again, the risk assessment must be prepared by someone that's competent in terms of developing it. But the overall goal is to identify your critical control points. These must be identified and identified in a manner that if it's a risk, then there must be a plan to prevent that risk. That could come from a design change, or it could come from an operational change to minimize that risk. It's that preventive action is to really deliver how to avoid the contamination itself. Now, the risk assessment format can come in a variety of examples. I provided an example here, which is nothing more than a simple Excel document itself. But that site risk assessment asks some key points. They ask to identify the risk by number, what is the observation, what is the beginning solution and the action thereof, what is your status, and what is, if it does require a resolution, what's the timing in terms of a date, and then what is the actual action itself, and then how often are you tracking that risk. Now, one point I'll emphasize with the FDA, there certainly is a lot of focus that the FDA is doing, particularly in terms of the drug environment, as well as even contamination from foreign suppliers that are selling food in the continental U.S. or North America. And an argument could be made that says, well, the FDA is just too busy. I don't see them show up at my facility. Well, you need to reassess that judgment. And the reason being is the FDA is assigning more third-party companies to perform those assessments, as well as what they're doing is they're sending letters of compliance to food facilities itself. And what they're asking for is, I need your year's worth of data that actually substantiate what you're doing associated with your risk and what are you doing to actually address those risks. And trust me, that request to pull the year's worth of data and results are far more than in terms of effort than it would be for the FDA inspector that would show up and say, show me. So the questions to ask in terms of the risk assessment development is who has access to those critical control points and the food material risk areas itself. Pay close attention to those 4 key areas that we mentioned, the mixing and grinding areas, the ingredient handling, the bulk liquid receiving and loading, and the liquid storage and handling. Those are focus areas that the FDA will gear toward the assessment and risk areas itself. So in essence, you should be prepared for that. The actual actions itself, you need to restrict access to what we call controlled environments. And that includes suppliers, contractors, and visitors, and most employees, limiting the access to those critical points, specifically within your food facility. Those controlled environments itself provide a higher level of protection, both in terms of airflow and material flow. It also supports video monitoring as well as physical monitoring. Now, this is a design in its simplistic block form for a facility design. And a lot of facilities that have been put together, and particularly in terms of a brownfield operation, is in essence what you have is a dirty side where you've got your raw material incoming flow, and you have a clean side where you actually induce micro control level. And in essence, in the middle, you have a kill step, which could be like an extruder that actually takes it to a 5-log position to minimize microbial risk itself. The problem with this design is you not only have material flows going back and forth between your dirty and clean side. So envision a forklift that its wheels are dirty and it's directly transferring that contamination from the dirty side to the clean side. Likewise, personnel flow need to be restricted from the dirty to the clean side. So in essence, objectively, what you want to have is a physical separation. You want to even to the point of even having badge control for your employees. You want to keep out your forklifts that are operating in the dirty side from even advancing or going into the clean side operation. This is the emphasis itself. Also in terms of the actual passage between the dirty and clean side, you want to maintain that even through a double door airlock. And in essence, what you want to maintain is an air pressurization to where the clean side has positive air pressure as compared to that dirty side. So you want to keep the dirty air out of the clean. So in essence, you literally want to have about a 10 to 15 Pascal difference between your dirty and clean side, and your airlock needs to be at least a 5 to 7 Pascal difference as a step up point. So in addition to the development of those risk assessment exercises, some of the key points is to ensure that you're developing equipment standards and specifications for the following: the bulk liquid receiving and loading, the liquid storage and handling, the secondary ingredient mixing and similar activities, again, those top 4, but also areas defined by the controlled environment. What you have in terms of any open product, whether it be in a tank or a pump, heat exchanger, or your primary packaging filter. Within your primary packaging, before it reaches that final package, it must be in a controlled environment itself. What's key is equipment surface finishes, your construction and piping standards, your site compressed air. Point of use, you should have that compressed air filtered to a 0.2 micron. Your site water systems are so critical in terms of keeping microbial control, in terms of having a robust RO or a deionized water system. And as mentioned in terms of the previous example, having robust facility design that manages not only the material but personnel flows also. Those equipment standards in itself is, and again, this is an eye chart, so I apologize for that. But the point that I want to identify is there's a level, in this case, there's a level of preferred clean design, a moderate, or even a high risk. And in essence, the high risk, which is listed in red, if it's designed to those standard levels, the risk is the probability that you will have a micro hit is very high. The overall moderate risk itself, if systems are designed to that level, you will probably have to have a operator intervention to maintain that risk control itself. Minimal risk, or the preferred clean design, are standards that assist a food facility to maintain the proper surface finish, the proper design, particularly in terms of having full CIP versus COP control. And that stands for clean in place versus clean out of place. As I mentioned, those equipment specifications, one of the key points is surface finish requirements. All your food facility material surface finish should be designed to an RA value of 0.8 micron or 32 micro inches. Now, I put this chart as a comparison to BPE standards itself, which calls out 0.41. But again, 0.8 micron level for a RA value is very achievable. I would avoid specifying surface finish like, in essence, like a 2B mill finish. A 2B mill finish, or examples of such as that, it's a subjective evaluation, where a RA value is actually measured with a profilometer. This actually measures the irregularity of your surface finish and minimizes the microbial contamination that could fall within the crevices of the actual surface finish itself. In addition to that, in this example, we provide equipment piping examples. So this is very paramount in terms of overall design for your piping system. What you want is a piping system that's fully drainable. So when I clean and sanitize, I can actually achieve full drainability. As I mentioned, there were 4 steps required by FSMA. The second step is, what are the actions associated with that? So again, the first question out of what are the actions to ask is, can I design the control point out? The second question is what are my operating procedures if I cannot design it out? As an example, with a tanker transfer hose, a procedural change may be to steam clean that hose, CIP, SIP, clean in place, sanitize in place, prior to each use. The third question to ask is there something in the process that minimizes the risk, as an example, the extruder kill step, within the manufacturing process itself? So depending upon that kill step, that may identify a potential risk adverse situation. Going on, the third item is, how do I know that my corrective actions worked? If I've designed it out, then you've solved it. There's no further risk associated with it. If a kill step is present within the manufacturing process, you must supply data that verifies that the kill step solved it. So in essence, if I have a kill step, am I killing to a 5-log rule? And again, the FDA will want to see that data. If it's a procedural mitigation, what are the procedures that are present that demonstrate that those changes are actually working? And finally, on the 4 steps required by FSMA, there must be a feedback loop to adjust the risk assessment itself. And that feedback loop ensures that the risks have been fixed or mitigated, or it may include another risk assessment performed to further resolve it. This could be further supported by using qualified outside organizations. An example would be the American Institute of Baking, AIB, to know that you're doing this assessments itself and that your control point and issues have been remedied. Next, we'll talk about cleaning and sanitization requirements to protect food against intentional adulteration. So a couple things in terms of intentional contamination. It can take several forms. It could be an act or a deliberate contamination, and that could take the form of chemical, biological, or radionuclear agents for the purpose of injury or even death. There is the bioterrorism that we often hear about in terms of potential risk. And those are generally toxins that are targeted at civilian populations. Biosecurity itself, again, those are preventive measures designed to reduce the risk of transmission of those diseases, pests, species, and even living modified organisms. Now, overall, cleaning and sanitization procedures are a preventive part of this biosecurity. For biological agents, accessibility is a measure of ease in which the attacker can physically access the intended target to intentionally contaminate the food. The vulnerability is a measure, to which that contaminant can be introduced. The production of contaminants themselves, the quantity, the storage and transport, and the technical expertise that go into that, with proper control measures, that can be identified through microbiological testing. Now, I'll stop right here because I want to focus on this picture. And I want to ask each one of you, what do you see wrong with this picture with this man's hand inside the tank? And is this individual wearing proper PPE in order to prevent contamination? So the net result of this in terms of observation is an self-examination opportunity. Is there something that we're doing as part of our operation in our food facility? Does our technicians, are they properly gowned in terms of performing cleaning and sanitization, and even the actual production of the food product itself? So in essence, you see the man's arm that's sticking into the actual kettle itself. Is that something that we want to promote? So the methods of intentional adulteration, again, it could be an exterior attack, force entry, a covert entry, and or insider compromise. Now, for covert actions and insider compromises, if a biological agent is used, cleaning and sanitization can help. So let's talk more in depth about cleaning and sanitization. The point that I want to focus in terms of this discussion is they are two completely separate steps. Cleaning is a precursor to sanitization. Cleaning has several or similar requirements in terms of design of equipment and facilities, and similar discipline is needed for both cleaning and sanitization, both in terms of procedures, the validation of its effectiveness, and the documentation at completion. Cleaning is also usually only tested against the product and not a threat, so the potential expansion is a part of the food defense plan, whereas sanitization is a reduction of microbial levels to where they don't prevent or present a risk to our process, product, or consumers. Now, people often ask me what is the duration for cleaning and sanitization? Cleaning can be any amount of time in terms of definitively delivering what is clean. So in essence, cleaning can be 5 minutes provided it delivers the intended result. Sanitization, however, is a follow-up step that must be performed either through chemical means or through moist heat application. And that's usually at a prescribed set duration of time at a specific temperature. And the point again about sanitization, it is not sterilization. In the food processing, we are not sterilizing. Focus is on reduction of micro risk versus elimination. Sanitization is essentially a preventive action that's part of our HACCP. HACCP being is our hazard analysis and critical control points. And it can be used as a corrective action depending upon the organism type and number. And it's already should be a part of our food safety plan. we should be applying it, cleaning and sanitization, both steps, after any kill step process. And the emphasis here is it must be validated in terms of repetitive action. Cleaning and sanitization alone cannot prevent adulteration. It can limit the scope, scale, and potential impact if the following are met: applied with the appropriate frequency, on an as-needed sanitization, and that sanitization is actually programmed, as I mentioned, in terms of validation. The system can be cleaned, and the conditions itself must be proven to be effective, and that all parts of the system are actually exposed to the cleaning and sanitization process itself. A point here on is that the food and beverage industry is very prone to bacterial attack, but cleaning and sanitization, fortunately, is part of the culture. Many people have heard about 3A dairy standards. That was actually originated through the dairy industry itself. A watch out here, however, is don't fall into the trap of extending frequency time beyond the allowable microbial contamination limits. In essence, we need to be cleaning at the end of each production run. The frequency of sanitization is defined by the risk itself, meaning the risk of contamination is a function of material susceptibility, as we mentioned the TVO example. Highly susceptible materials is going to require very potentially a higher frequency of cleaning and sanitization. Sanitization after every batch or lot may be a lower risk, but some materials that may have low susceptibility can be carriers. Our economic and reputation damage against the health risk must always be evaluated, and the best form of food defense against normal or even intentional adulteration. So cleaning and sanitization in summary, the equipment and process must be designed to be cleaned and sanitized. Objectively, we should be targeting to have systems that are fully CIP, clean in place, sanitize in place capability versus clean out of place and sanitize out of place. The risk itself depends upon that susceptibility of the materials and the control measures itself. If we do have a kill step and it's late in the process, the objective is to minimize the actual risk need itself. The frequency is the key for sanitization, cleaning and sanitization. We want to optimize between risk and impact. And as mentioned, it must be a validated process. The overall risk itself, accessibility control is key. We want to have a process that has a lower risk, but integrated with other risks within our overall food defense plan. Our biological agents, as noted, is one of the hardest contaminant to produce, and the consumer and customer perception of risk is very, very high. And damage that would have been done will also damage our supply chain base itself. Actions to support FSMA, specifically to Subpart L, and review again, verify that your employees know and understand your company's food safety plan. Make certain that they understand the FDA and FSMA requirements associated with overall food safety, particularly in terms of where your operational document is current, complete, and detailed. You know, assess your written food safety plan. Look for gaps. Look for food safety policies, HACCP, Alliance, allergen management, and even your current good manufacturing practices. Confirm your company's policies are visible and being followed, including separation of personnel and material flows away from controlled environments. If you recall again, the facility design in terms of separation, the dirty from the clean side. And we want to ensure adequacy of the internal audit program to FSMA requirements. Utilize your vulnerability risk assessments to prioritize the equipment and building design standards. That is very key part of your food defense plan. That concludes the presentation. I'll be open to taking questions from the group.
Thank you, Dennis. For those in attendance, please do write any questions that you have into the question panel, and we will get those answered for you. And I do already have one, and this attendee echoes, thank you, Dennis, and then asks, the FDA plays a critical role in protecting the United States from threats such as emerging infectious diseases, including the coronavirus disease 2019 pandemic. Do you anticipate the FDA implementing guidelines for the FSMA for COVID?
Yes, I do. Yes, I do, in a manner that the emphasis here and whether it's interpreted as this self-interpretation, and I want to ensure that this is a self-interpretation. FSMA and the FDA actions itself, it's no secret that their focus right now is on the drug facilities itself. That and the point that I want to emphasize is being replaced with third-party assessments performing those audits for the FDA, as well as the written requests that show up in the mail that says, give me your 1 year's data that validate your risk assessments and your overall food defense plan itself. A couple of keys in terms of COVID-19. Microorganisms itself can be either classified as gram-positive or gram-negative. A little bit of history in terms of that is generally 95% of the gram-positive materials are safe. You know, an example is yeast for beer. However, anthrax is a gram-positive, so certainly that is not safe for us. Whereas COVID-19 is actually a gram-negative. Gram-negative, 95% of gram-negative particles are harmful to humans. And what's interesting with the COVID-19 particle itself, you know, I mentioned the compressed air standard of having 0.2 micron. Even our very best HVAC HEPA filter grade that filters air down to a 0.2 or 0.3 micron level, which is HEPA grade quality, hospital grade quality. The actual COVID-19 molecule itself is actually smaller than 0.2 micron. So you may ask, well, how am I stopping it? Well, the reality is you may not, but the only thing is that the value of COVID-19 actually attaches itself to other particles. And that's generally what prevents, you know, the introduction to its attack zone, if you will. So again, it's just a little bit of information. You may use it, you know, but again, keep in mind COVID-19, when they say it's the invisible enemy, it truly is. Next question.
Yeah, no, thank you. And that was a very timely question. I'm currently not seeing another question in the question box, so I want to give everybody a chance just in case they're typing. I did see really quickly that someone hit the raise hand, but then it went down, so I couldn't see who it was. If you're having problems using the question box, feel free to throw it in the chat. I can pull it from there as well. Or it may be that you just accidentally hit the raise hand button, and that's fine too. So I'm just going to give another minute or two in case there is another question or further questions. And it may be that people are kind of still processing, you know, all of the information and how it applies to their work. So as Dennis mentioned at the beginning of the webinar, he provided, you know, his contact information was here on the slides, but I will also place it in the email that everyone will get that contains the recording. So should you need to follow up with him directly, you know, if questions occur after the webinar, you will have the ability to do so.
Yes, to help support that, the Plus Group, myself individually, would love to help companies, like those that are in attendance. The other thing, Amy, you may want to mention that the actual presentation will be accessible via AOCS site next week. Is that correct?
Yes, we should have everything available for the attendees early next week. And I will send you an email that'll have the recording, a link to the slide deck, as well as Dennis's contact information and your certificate of attendance. So that'll all come early next week. If for some reason you miss it, just get in touch with me and I can resend it to you. And so I'm not seeing any further questions at this time. So I think with that, we will end the webinar. And 1 second though, the hand raise just came up again.
All right.
Let me, and it went away.
Okay. Maybe it's just someone teasing us.
Well, it is easy to accidentally hit. Yeah. I've had that happen though. And then you're like, oh no, unraise my hand.
No problem. No problem.
So, but there is a question box and a chat box. But like I said, if for some reason you're having an issue with your control panel, you're going to be able to get in touch with Dennis directly. And if you have like a pressing question and didn't catch his contact information at the beginning, send me an email and I'll send it to you right away.
Yeah, I'll just flash it again if that's of value, so that people can. Let me get back to the beginning here, and that way people can actually see.
I'll give everybody a second to write it down. You can also get in touch with me if it's not convenient, and I'll get it to you.
Yeah, it's listed at the bottom of this slide, and the actual, again, work and SIL and personal company email.
Awesome. Thank you so much. Thank you for your presentation, as well as your willingness to share information afterwards with the attendees. I really appreciate that. And thank you everyone for taking the time today to join us. I do hope you enjoyed the webinar. With that, I'm going to close. Thank you, Dennis.
Thank you. Thank you, everyone.